Welcome, new technicians. Today, we're diving into disc brake service. It's crucial for safety and customer satisfaction. We'll cover removing and replacing rotors, proper machining, and installing new pads and hardware. Let's get started. First, rotor removal. Rotors come in two main types: integral, where the rotor and hub are one piece, and non-integral, where they're separate. If you have an integral rotor with adjustable tapered roller bearings, you'll remove the dust cap, then the cotter pin and castle nut. Be careful not to drop the outer wheel bearing when you pull the rotor assembly off the spindle. For non-integral rotors, they usually unbolt from the bearing hub. Sometimes, the hub itself needs removal first. Rust can be a real headache here. Look for two threaded holes in the rotor hat. Those are your friends. Thread in some appropriate bolts and use them as pullers. If no holes, a sharp rap with a dead blow hammer on the rotor hat, never the braking surface, can shock it loose. Penetrating oil is also your buddy. Remember, on some floating or sliding caliper designs, you might need to remove the caliper anchor assembly first. Before deciding to resurface or replace, measure lateral runout. This means how much the rotor wobbles side to side. Mount a dial indicator on a fixed suspension component with its tip on the middle of the pad contact area. Zero it out, then slowly turn the rotor one full revolution. Check that reading against the manufacturer's specs. If it's excessive, you'll need to machine or replace the rotor. If resurfacing, you have two options: traditional bench lays or on-car lays. Bench lays are great for integral rotors with tapered bearings. Make sure to remove the inner bearing and seal. Non-integral rotors might need special adapters. Always check runout on the lays itself to ensure proper mounting. On-car lathes are often specified by manufacturers because they machine the rotor exactly as it sits on the vehicle, eliminating runout issues from mounting. With on-car lathes, always clean the rotor hat and hub mating surface thoroughly. Rust and debris here will cause problems later. When machining, remove only what's necessary. On ventilated rotors, remove equal amounts from both sides. And for rotors on the same axle, keep them within 0.010 of an inch of each other. Surface finish is critical. Fine grooves left from machining can cause noise and vibration. Adjust your lathe for the proper finish. You can also apply a non-directional swirl finish using a sanding block with 100 or 150 grit sandpaper against the turning rotor for about a minute per side. After machining, wash the rotor in hot, soapy water. This opens up those tiny grooves and thoroughly removes any leftover material. This is crucial. Never use aerosol brake cleaner for this step. The cold propellant can actually trap debris, leading to noise later on. Now for installation. For non-integral rotors, thoroughly clean any rust from both the hub mating surface and the inside of the rotor hat before installation. Always avoid getting grease or dirt on the rotors or new pad linings. On integral rotors, pack the wheel bearing cavity and bearings with high-temp grease. Install the inner bearing and new seal. Then install the rotor, outer bearing, washer, and finally, the castle nut. Always adjust tapered roller bearings per manufacturer specs and install a new cotter pin. Before installing pads, confirm they're the correct application. Newer vehicles often use ceramic pads. If you use semi-metallic in their place, expect more noise. Make sure all caliper hardware, bushings, pins, or keys are in place. Lubricate mating surfaces on sliding calipers and caliper bushings and pins on floating calipers, using appropriate high-temp lubricant. Install the pads with any anti-rattle springs, clips, or shims. Best practice is to replace all caliper hardware during a brake reline. Finally, install the caliper over the rotor and torque the mounting fasteners to spec. Last but not least, burnishing new pads. This breaks them in, burning off bonding resins. The 30-30-30 rule is a good general guideline. 30 complete stops from 30 MPa with a 30-second cool down between stops. Always check manufacturer specifics for variation. That's a quick overview of disc brake service. Practice these steps, follow manufacturer procedures, and you'll ensure safe, quiet stops for your customers. Thanks for watching.